Hi there and welcome to my channel. Today we are diving in an important topic, airflow mixing. We'll discuss why it is being used, its applications, and calculate the resultant airflow using Mollier diagram with two methods. Whether you are working in the software for air handling units or just looking to improving ventilation in your home, stick around to gather some valuable insights. I enjoy sharing my knowledge about the psychrometric chart with my colleagues and students because I believe that working with this diagram is a great way to deeply understand the dynamics of changes in the air parameters. While there are many programs nowadays about the ventilation works and electronic Mollier diagrams, I firmly believe that manually working through those calculations is highly beneficial. It helps build a solid foundation of knowledge for the aspiring engineers and anyone interested in the real-world physics. Airflow mixing occurs when two or more air streams combine. When we are opening a window, it will provide the outdoor air mixing with the existing indoor air. In air handling units with air recirculation, their mixing is occurring in the mixing chambers. Mixing allows us to balance between air quality and energy efficiency. Fresh air ensures we reduce contaminants and increasing oxygen levels, while recirculated air helps to conserve energy by reusing deconditioned air. It is widely used in premises in which heating or cooling is provided by ventilation. Number of occupants is changing drastically, such as cinemas, theaters, and shopping malls. Intensive air exchange is designed for air purification. For example, surgery rooms or big kitchens. And when intensive air exchange is designed for dehumidification. For example, swimming pools or water parks. As an example, let's take air handling unit which uses 80% recirculated air and 20% outdoor air. The goal is to calculate the resulting air parameters. Step 1. Gather your data. Outdoor air parameters are plus 5 degrees Celsius and relative air humidity is 60 degrees. Return or recirculated air parameters will be 22 degrees Celsius and 40 degrees relative humidity, and 40% relative humidity. Step 2. Plot the points. We'll use a psychrometric chart, also known as Mollier diagram or HX diagram or ID diagram, to acquire the necessary air properties. This diagram shows relationships between air humidity, temperature, and other air properties. So I'm plotting those 2 points down in the Mollier diagram. Let's go down via the enthalpy line to get enthalpies of this air. And we're going straight up via moisture content lines to read the moisture content in our parameters. Let's write down those numbers, and the calculation part I will show you in a spreadsheet file. So I've put a little table there for our 3 points, so outdoor air, recirculating or return air, and mixing air, using air densities for the points taken. I've calculated the mass flow for each air parameter. To calculate enthalpy of the resulting airflow, I will use the average arithmetic formula in which the first point enthalpy will be multiplied by mass flow plus enthalpy in the second point multiplied by the mass flow in the second point, and all the sum divided by the resulting mass flow. And a similar way I will acquire moisture content. So We've got enthalpy and moisture content of the resulting airflow. Let's draw one line via enthalpy line, other line via constant moisture content, and that way we have gotten the third point is the air. Those are air parameters of the mixed air. And the second way to calculate mixed air flow parameters using Mollier diagram is by using angle of the process line. In this way, let's draw a line between our entering air parameters and divide it in the equal proportion of our recirculation rate. I've just measured this line on my screen and got completely equal results to our calculation which we did before. So how does this apply to non-professionals? Every time you open a window, you are initializing of air mixing process. The outdoor air is mixing with the existing air in your room. If you don't have any other ventilation, please do this regularly, at least once at 1 or 2 hours, by opening windows wide and holding such for about 5 minutes. The air outside helps to reduce CO2 levels and refreshes the environment. The bigger is air parameter difference between inside and outside, for example at winter, the faster ventilation you will get. Whether you are making calculations with a Mollier diagram or just cracking a window, small changes can have a big impact. Thanks for joining me today. If you found this video helpful, don't forget to like and subscribe for more tips on HVAC, engineering, and improving your indoor environment. See you all next time.